Hi everyone, welcome to the channel. Today we are diving into word of stream gatherers, a super powerful feature in Stream API that is changing how we handle data streams and intermediate operations. So stick around because we are able to explore the coolest feature of JDK 24. Let's go through what we will go through in this session first. So in this session we will start with gatherers introduction. Then we will see a demo, what we have to do without gatherers, what was the problem, why gatherers was created. Then we'll go to the parts which creates a gatherer, which are integrator, mutable state, finisher. We will also look at parallel gatherers. There is a factory class given by Java, and they have predefined methods, some predefined gatherers in it, and so we'll look at them. Then we will see life with gatherers, which means the code which we did without gatherers, how it is very easy and readable with gatherers. Then we'll go for conclusion. Let's look at what the JDK has given us in terms of gatherers. So we have an interface named gatherer. It has an integrator. So this is also a functional interface, and integrator is also a functional interface. We also have a factory class named gatherers, which consist of some of the methods which you can use. They already have some of the gatherers already created in them. Also, we have a method named gather in which you have to give your gather which you have created. So let's look at what was the problem we were facing before gather. So here I have a record named books. Books has a lot of fields, as you can see: ID, title, author, summary, category, and published date. To see what was the problem before gatherers, what we can do is we can attempt this use case and it will give you better understanding. So let's say I want to get two latest published books per category. So before gatherers, what we have to do is, let's say we have to take the books, stream, then we can collect them. We can group by them using categories first of all. And then then what we can do is we have a function in group by called collectors. So after grouping them into categories, what we can do is we can collect the books to a list, and then I will be using this books here. So let's add some comment here. Collect books to list, and then I will be doing some operations on it, like sorting first. What I can use is I can give a comparator comparing with book published date, and then we need to reverse because we want the latest published books. And then what we can do is we can limit it to 2. Then we can, instead of this, we can so we'll be adding some comments for you to follow. Sorting by published date, limit to 2, and then we can collect. Let's look at gatherers, all the elements we need to create gatherers one by one. So if you see gatherer, right, we have an integrator in it. Integrator is also a functional interface as well as gatherer, which is also a functional interface. So what we can do is, let's say I have a list of words and I want to filter it. So we will create some of your known intermediate operations in gather to better understand it. So what I will do is, here I'm not creating a filter gatherer. I will be creating a gatherer. So as gather is a functional interface, what I can do is something like this. I will copy it, I will paste it here, and then as this is also a functional interface, I can do something like this. So this is my gather, but this it does nothing. Basically, what it will do is it will take your element and won't do anything, and it will not return anything to the downstream, and it will like return nothing. So as we are going for readability, this is not the most readable way, as you can see. So what you can do is you can use a method given, which is gather gathers gatherer of. So gatherer of is a function uh, given by this gathered interface. uh, I will open the outline structure to show you. Yeah. So we have one with the integrator, one with integrator finisher, one with uh, initializer integrator, which is of sequential. So we will also see sequential and parallel gatherers, and we have much more methods. So we'll look at off ones. So if you see integrator, right? Let's look at integrator first. If you see integrator, it has three generics. The first one is the state, which is the mutable state. We will also look at that. The second thing is the type of element this integrator will consume. And the third one is the type of element that integrator will produce back. So whatever the upstream will give to the integrator, this will be the type of element, and whatever our gatherer will give back to downstream, this will be the type of element. So instead of this, we can have some logic, which is if element, which is the incoming element, dot length greater than 3, we will push it to downstream, and others will return true. So I will let you know what return true means. Here we have a gather which will filter if the element length is greater than 3, it will allow it, otherwise it won't allow it. If you want stream to keep pushing it in gatherer, then you will return true, otherwise you can return false. So when it will be used, I will show you in a demo later. So for now, let's run it. As you can see, only this has length greater than 4 and it has only passed this, but we are checking on the whole string. This is the basic gatherer we have. Let's go to mutable state. What is the mutable state in the gatherer sort of? I will show you here. So sometimes you will need some data type to mutate. So let's say if you want to get some distinct elements from your stream, you might be needing a hash tag. So you can keep storing your elements in it. Once you have all the distinct element, you can push back to downstream. So that's why you need a mutable state. Here I will be writing an example of drop while. So drop while function we have already used in our day-to-day life. So we will be creating our own this time. So let's create a criteria. So I will be going through it. Should be integer. So the criteria is that I should be greater than 4, and we will allow it. Once I is greater than 4, we will do something on it. So I uh, I should be greater than, or we can say once it is 4, we will allow the stream. Will allow the stream downwards. So we have created a criteria. Also, I will be creating a simple class which will have uh, not downstream, we can call it enable. So once we have this enabled true, then we will allow everything in the downstream, and that will be enabled once our criteria is met. So we'll drop while I is not equal to 4. Once I is equal to 4, we will allow the downstream. So how we can do this? I will be using gatherers of sequential here. Sequential and parallel gatherer will talk later on, but sequential gatherer will be run by only one thread. So what I will be doing here is having my own initializer here. So switch, I will be creating a new object of switch that will be used by that thread and will be initialized only in my gatherer here. Uh, then I will be having the same thing, which will be this here. So here I will have my switch. We also can have switch here, which is the mutable state, as we all know. So gatherer has the same generics. I forgot to talk about it. It is the same T operation, which is the input, R is the output, and A is the potential mutable state. Same we have here in our integrator. The switch is the first, and the element is the second. Which is a keyword, so I will be removing this. It is causing issue. Here I will be returning name. So now what we'll do is, if our switch is enabled, so our switch will be enabled once only after we have reached to 4. So if it is already enabled, we have to just push it. Else we will check in every condition if our criteria is met or not. So criteria test element, if it is met, we will make it downstream to push the element, and we can do. So once we got 4, we will enable our switch. We'll push 4 to downstream, and after that all the elements will go to downstream. Else we will not push anything to downstream, but we will return true, because we, let's say if we have not matched the criteria and it is not even true, we want to keep going through. One more thing I want to show you is this downstream dot push is will return you a boolean, which will tell if more elements can be sent to downstream if it is accepting the elements or not. So instead of returning true here, we will be returning downstream dot push, downstream dot push. So here, if so, as you can see, our drop file is ready. So what we will be running it once. So let's say if it pops. Yeah. So once we have reached 4, our switch is enabled, and we have pushed this for downstream, and once it is enabled, it will push it. Otherwise it will keep returning to, it will tell that I need more elements here, I need more elements here, I need more elements here, and then once it reach 4, it will allow everything. So this is the mutable state, you can put it here. And as per the sequential gatherer, only one gatherer will run this gatherer, and it will use this state, and it will be passed with every integrator. Every time, every element, every integrator, it will pass with it, and they will mutate it. Okay, let's go through finisher. So why we need finisher, I will show you after writing this example. So let's say you want to sort as well as make your stream distinct. So how you can do this? Here I will be using the same thing. So gatherer of sequential. So uh, here instead of a switch, what I will be doing is I will be having a new preset which automatically does some things for us. Uh, uh, then uh, I will have set element and downstream here. Here what I will do is I will be adding the element to set and will return true. Forgot. Uh, so here I have added the element to the preset and return true. So I am accepting all the elements, adding it to set. Once I have added it to set, what I can do is I will have one more thing, which is my finisher. So this will be my finisher. Finisher will have two things. Let's see it. So your finisher is a by consumer. So it will accept two things and won't return anything. So it has accepted two things, our mutable set and a downstream. Here what we will be doing is we will be pushing every element to the downstream. So we have the set. So let's change the name here. We will have set, and then we will have a stream. And what we'll do is uh, for each downstream dot push. Here we have an issue. The issue is let's say your downstream is not accepting any elements. If it is not accepting elements, let's say I have something like limit 3 here. So if it is not accepting elements more than 3, no error will happen, but it will be wasting your CPU cycles. Will not be doing anything with it. So if you have something like limit here after your gather, and but you are processing everything, so stream will tell you if it is accepting the elements or not after this limit. So what you can do is you can check if your stream is accepting the elements or not. We have a method for this. So I will be removing this. So what I will be doing is use take while. Take while if downstream is rejected. So here I have used a unnamed parameter. This is also a Java feature because I don't want to do anything with stream. I will check while the stream is accepting. What I will do is I will push. So this will only work if you have called downstream dot push. So in the starting, it will be always accepting. It can only go from accepting to rejecting. It cannot come back. So once downstream dot push is called, it has returned false. Then it will become rejecting. It will become true. So what I will give is, I think this is wrong. Yeah, no. So now if we remove this limit for now, what I will run this once. We are getting all the elements sorted. If I put this limit, uh, we'll be checking if it is rejecting or not. It will only print 3. Even if I don't put this, it will waste my CPU cycles. Also, what we can do with this is one more thing. We also have all Yeah. So all match will stop pushing once it is false because it returns the boolean. So this also will work for you. I think let's run it once. Yeah. So let's go to parallel gather. So what I will be creating here is I will be creating a distinct intermediate operation for you. So it will fetch, get all the distinct elements in the stream and will return it. What we can do is first I will be showing you a sequential gatherer. Here we'll be doing the same thing. We'll be having a tree set. With it, we'll have the same thing. So let's copy. Yeah. So instead of this, what we can do here is easy. Let's not have this. Yeah, it will be easy to understand now. So if set dot add element, I believe it returns something back. Yeah, so it will return true if it has added an element. So what we can do is we can push downstream dot push, and we can return true. Okay, we have hash set here. So not have to use reset because we don't want it to be sorted. We just want distinct elements. So we will be running this once. So this is a sequential gatherer. As you can see, we have distinct elements. So this is a sequential gatherer here. I want to show you some image. What will happen when we have a sequential gatherer? So let's say you have upstream, right? If you make your stream parallel, so like here, what you can do is you can. So if you have your stream as parallel, what will happen is all the methods before sequential gatherer will be run by a lot of threads, multiple threads. The sequential gatherer will only be run by one thread, and the downstream will be run by multiple threads. We will also see a thread count demo later on in this session. So as you saw, we have a sequential gatherer. uh, so what you have to do for running it parallel really in this is to remove this sequential from here. What will happen after you make this as a sequential uh, gatherer is like this, that all upstream will have multiple threads, or gather will also be run by multiple threads, and downstream will also be run by multiple threads which are parallel. So what will happen is this mutable state which we have seen will be one per thread. So every thread will have its own mutable state. So once you have this mutable state for every thread, you will need a combiner. So combiner is nothing but your similar thing. Let's say we have two sets after this. We need a way. We have two head sets after this. We need a way to combine this set. Also, we will need a finisher, but I don't want to use it anyway now. So what we'll do is we will use add-on. Yes, that's good, and we'll return this one here. So what we have to do is let's say multiple threads have this hash set, and we are adding the elements. So let's say some hash set will have this, this, and the second one will have this. Multiple parallel threads will have multiple sets, and at the end, when every processing is finished, you will have to combine those threads to give a singular set here. So you will need to have this. But the issue is now if you see this code, this logic will not work. because this will be run by multiple threads, and we are pushing in downstream using this. So this thread dot add will go false if we already have the element. So let's say we have two threads, which one has the element 10, one has the element 23. The second thread is having the element 30, and the second thread will also be having 23. So this 23 has got into multiple sets, and we have pushed it to downstream. But this will not fail because the other thread, the other set, which is with the other thread, will have this element 23, and this will not have, and it will allow it. So what we can do is, instead of pushing the elements here, we have to rethink our approach. So instead of pushing the elements here, we can just add it to the set. Then we'll combine it here. And after combining, we can use our downstream, which will be set downstream to do this. So it will be, see, we can just copy paste set stream dot all match. So now we have also checked if it is pushing, getting the elements or not, downstream is executing or not, and we have made it valid. Let's move to how we can solve our initial problem with gatherers. So we have a class name book gatherer. Here we will be creating our own gatherer. What you can see is we have a key extractor here as a method parameter. Key extractor is nothing but when we have to get a key from books, it can be either category or anything. So I have make it a method parameter. Same with the comparator. Previously we were comparing with published state. You can use any comparator, and limit also I have made it as a method parameter. Also you will be able to see is we will be getting book from upstream. Our mutable state will be a map of key and list of books on which we will perform the operations, and what we will return is map entry, and that map entry we can convert it to map later on. So let's start. Instead of return null, what we can do is return gatherer of. Here we can have our mutable state, which will be hash map. Hash map here will be of type key and list of books. Then we will have our map here with book and downstream. Downstream we will not be using here, so I will be making it a unnamed variable. So book, remove this. And map. So what we can do here is we can get key from the key extractor first. So let's add comments. Get key. What we are doing, so we can follow key extractor. We can apply and get the key. So we will be giving it a book. So let's name it book instead of. Make it more readable. Once we have given it the book, what we can do is, next thing what we can do is map dot compute if absent. So if it doesn't exist in our map, what we can do is we can add it. So key, we'll see if key exists in our map. If it doesn't exist, then we have key here, and we'll have a new array list here in which we will add our book size. So array list, and then we can use add, then we can have a book, then return to then what we can have is our map This is our combiner. So I won't be using combiner here that much. So I will just be returning map one back. You can add logic to combine the map, but I won't be showing you the parallel stream, so I'm not doing anything. This you can ignore. Uh, Add list if not exists for key, and you can return to so accept items. Here now I have my finisher is map one, and not map one, we'll call it map and downstream. Here what we'll do is for each map we have uh, key as the key and book as the value ring. So we can put the operations here. What we can do is for every category and a list of books, what we can do is we can perform the operations we have to. So it will be, let's name it books. So books dot stream. We can sort using the comparator. So comparator is given to us, and then we can use limit. Limit is also a method parameter. Then we can uh, get collected to a list. So once we have this, we can push uh, the map entry like this. Push dot entry. So let's use our gatherer what we created, and we'll compare with the function we created previously. So I will minimize it. Let's use the same function. We'll change it to gatherer. Uh, we'll copy some things from here and this. So what we can do now is we can use this books to stream, and then we can use gather. We can use the gather we created. So books gatherer dot create sample gatherers. In this create sample gatherers, first we have to give the key extractor, right? So our key extractor will be category. Then we can give the comparator. So I can use the same comparator here. Then we can give the limit. So we will make it. Let's collect it to map. We can use to map function, which will take map entries. So now we have the map. As you can see, it is quite readable than this function we previously created. This is a lot elegant and will be easy to read, maintain, and also review. Let's run it once. Yeah, so as you can see, it is giving this results. Let's look at some of the inbuilt functions of Gatherer's factory class. Uh, Here we have fixed window size. So I will be running them once so that you guys can see it running. So fixed window size will return patches of fixed windows. Here I have given size 3 and I have limited to size 9. So it will give 3 windows of size 3. Let's run it once. As you can see, it has given 3 windows of size 3. Similarly, we have fixed window sliding. I will be running this first. Here how it will work is it will have fixed windows of size 2, and then it will slide one by one. So let me run it for you to understand better. Yeah, as you can see, the first window is 1 and 2. Then it will slide by 1 to 2 and 3, 3 and 4, and it will go till 9, as you can see. Let's run the third method, which is fold. So the fold is quite interesting for me. Fold is like reduce operation we already have in Stream APIs. But here we can use it as an intermediate operation. As you can see, I have got out all the title of the books. So let's run it one. As you can see, it has printed all the title of the books. Similarly, we have scan function, which is similar to fold, but it will also print out all the intermediate result of reduction operation. So let's run it once. Yeah. So as you can see, it is printing all the intermediate results and reducing everything one by one. So the best function for last, map concurrent. Map concurrent function is one of my favorite function in the inbuilt functions we have. So let's see why. So if we see map concurrent functions, we have concurrency level, and then here I am trying to replicate some huge time taking function. So it is a way for your gatherer to run parallel, even if your stream is sequential. So here I have given concurrency of 4. So even if my stream is sequential, I will have 4 virtual threads running my gatherer in parallel. As we can see this diagram, uh, if even if my upstream and downstream are sequential, my gatherer will be parallel, and it will be run by 4 threads as we saw in example, because I have given the concurrency 4. It is just opposite to the sequential gatherer we have, where our upstream and downstream are parallel, but our sequential gatherer will only be run by one thread. Let's jump into gatherer parallel thread count demo. So this is quite interesting demo. I will show you of the last 2 diagrams I showed. So basically, I have 3 sets in which I will be storing my threads, which will be running my upstream gatherers and my downstream. So as you can see, I have a range of this, and I have mapped it to thread.getName. I am adding all the elements which I have mapped to this upstream threads, and I have added the gatherer thread here, and then I am using this p function to add the downstream threads. So the sequential gatherer is using off sequential function, as we already talked previously. So let's run it once. So as you can see, we have upstream ran by 12 threads, but the gatherer is run by only one thread because it is a sequential gatherer, as we saw in this diagram. We can see the downstream is ran by 11 threads. Let's see the parallel demo. The difference between these two methods is just this: I'm using a parallel gatherer here instead of the sequential gatherer. So let's run. So as you can see in this diagram, upstream, gatherer, and downstream are all running parallel by parallel threads, as we can see in this diagram. So guys, in conclusion, what I can say is, if you already have an intermediate operation that is doing your work present in Stream API, use that instead of creating your own gatherer every time. Gatherers are a way so that if we don't have any intermediate operation like filter and other things which are doing our work already, doing what we want to do, actually we should use them only instead of creating our own gatherers. But if you don't have any functions which are doing what you want to do, you can create your own gatherers. So guys, thank you for watching. If you like this video, please hit the like button and subscribe as I will be pushing more videos soon. Thank you so much.